All right, so fortunately, the other session that's going on right now must be way better than mine. And I'm the only thing standing between you and lunch. In addition, due to some of the performances of my last, or some of the prior performance of me giving presentations has resulted in me needing some assistance. So do you all know Christian Mosier? Okay, Christian Mosier has decided reluctantly to help me out on this presentation. So feel free to ask lots of hard questions to him.
Yes. I mean, you explained before that we have started working. I also worked 40+ years with VMS. I started with PDP and RT and then VMS. And we have known each other for over 30 years.
Yeah.
And we have spent numerous times together working on a customer problem and spending time with live customers trying to solve the problem. So
we have independently walked out on the same customer for similar reasons of frustration.
Yeah, because we had to fix a problem, but you're not allowed to make any changes. Yeah. So the problem doesn't go away. Yeah.
All right, so what we're going to do, Christian is going to kind of start this material, and then we'll work together from there.
And very fun. Do something wrong, then.
Yeah. If you make a mistake, I'll help you out.
Look at the right one, yeah. So basically, when you work with customer problems, I mean, the first thing, rule number one is to don't believe the customer, trust facts and data. I mean, that's rule number one.
Customers always lie.
Yes.
The corollary is they may not be aware.
So they report a problem and you ask them, did it ever work? Or is this something new? And they said, yeah, it worked last week. And then, of course, you follow up and say, so what has changed? And in 99% of the cases, they tell nothing. And again, I mean, so some of them, they think nothing has changed or they want to cover up. And I normally tell them, look, I mean, you better tell me now, it saves time because I'll find it out anyway. So basically, yeah, that's, I mean, you've been to customers, you walk in and there are 10+ people in the room, storage, network, OS, application, and everybody's accusing the other one, like, oh, the database is slow. And the network guy says, oh, it's all green. I mean, it's like, it's good. I mean, so they never see the spikes or whatever. So, yeah, so that's why, I mean, like, believe facts and give me data. And then sometimes, I mean, yeah. So what has changed and how slow is slow? I mean, like they say, I mean, it's slow, but was it ever fast? And what? And especially sometimes overnight, I mean, you have the whole night, which is like, whatever, 12 hours or depending. Does it run in 1 hour or 1 hour 5? But if it's in a bank where the close of end of day processing goes into the morning before the bank wants to open, then yes, it's a serious problem. And yeah, they like things are not always as this.
Get numbers.
Yeah.
Draw a graph. Write on the whiteboard. Here's what it used to be. Here's what it is now. We've been at customer sites like, oh, it usually runs much faster.
How
much faster? So we go back and look at the log files. Do you have those? Sure. You search the log file for elapsed. It's right at the very end. It's all over the map. You know, one day it's 10 minutes, one day it's 30 minutes, one day it's an hour and a half, the next day it's 2 minutes, because it's all data dependent. So like, oh yeah, last night it ran for an hour and a half. Well, it ran for an hour and a half 2 weeks ago as well. But, you know, so develop what the model is. What are we looking at? And document it right on the whiteboard. Get everybody in the room to agree. Yeah, that's how long it really took. Cuts down a huge amounts of arguments. Mostly us defending the graph.
Yeah. And yeah, like we said, I mean, wall clock is not always because it's all data dependent. I mean, it's like, I mean, I've had customers, they say, yeah, my backup is very quick. It's 10 times faster than it was 2 weeks ago and a month ago. But when you try to restore, the data isn't there because it wasn't backed up or whatever.
Yeah, and for IT professionals saying 2 hours, the job runs for 2 hours. Okay, is that a good number or a bad number? If it's 2 hours of CPU time and 100,000 IOs, that's a lot different than 10 minutes of CPU time and 1 billion IOs. And so building the relationship between buffered IO, direct IO, CPU time, and elapsed time is super limiting. I'm not going to spend a lot of time working on your storage for a CPU-bound application. But again, still takes 2 hours. So establish that relationship. Find out what is the rate, the latency.
And like a computer is very reliable. I mean, it does what you tell them to do. And if you tell them to do something wrong, it does it wrong even tomorrow. I mean, so basically what you want to execute useful instruction. You don't want to wait, and you don't. And that's what the previous slide said also, like by the direct IO, buffered IO limits and all that. Even today, I mean, many of the old tools I mentioned, I mean, they are still the maximum IO size is like, do it small. I mean, because it might take too much memory for the buffers, and do only 2 at a time, because not 10 at a time, because whatever. So that's why I said, I mean, quotas and IO size, block size, whatever. I mean, if the block is too large, I mean, the disk adapter will chop it in pieces for you. I mean, you can still do one QIO with whatever large number of bytes, and the device will chop it in pieces underneath you. I mean, don't be afraid.
The defaults in VMS were established in 1980. They were probably wrong then. They are absolutely wrong today.
But you know why? Because backward compatibility with the
Yes.
card reader.
The card reader driver is why we have.
Comes back to the card reader.
Yeah.
But like you said, I mean, parameters, I mean, make them large, like page file quota is a favorite of Norm. But he has been also beaten by that because he went so high that he was running out of P0 space.
Yeah, right. That one,
So, yeah,
I'll accept that one.
Yeah. And of course, like a lot of customers, they try to, instead of fixing the real thing, to just, your car doesn't work, buy a faster car or whatever. I mean, it fixes temporarily your problem, but then, like, for example, end of day processing, if your data is growing, I mean, at one point, I mean, buying new hardware is not always solving the problems.
It feels good. It feels good. And your sales guy is good. Your CIO is successful, goes to the board and says, we're going to spend $100,000 and solve these problems and yada, yada, yada. But there's any number of cases where you could have spent a lot less money and fixed the application and gotten it 10 times better instead of 10% faster.
And that's also why I could never be a sales guy. I was down in Venezuela many years ago at a large customer, and they moved from whatever system to another system, and it was going slower. And then the sales guy wanted to propose another upgrade, and I said, no. I want a system with less CPU or less cores or whatever. I mean, like basically cheaper solution, which made your system faster, because that was all the NUMA effect what we had and all that. So they were just trying to sell more stuff. So of course I was the bad guy because the sales guy couldn't sell anything. But I said, yeah, you don't need that. So
Christian and I have both over the years walked into customer sites. I can vividly remember one, also in South America, but they had just purchased 3 brand new Alpha, whatever it was at the time, in a glass wall computer room. I spent Monday looking at the cluster and this and that and the other thing. I said, the best thing you can do is turn off 2 of those computers. And the sales guy, his jaw hits the floor, and the CIO guy is like the colors draining from his face. But yeah, more hardware is typically not the right solution.
But then once you have the hardware and you have all the memory, use it. I mean, I've been, not as a VMS, but it goes in the same state of mind. I mean, I work with databases and all that. I mean, like the customer, they have a terabyte of memory. And the SGA or the database is using like a couple tenths of gigabytes. And then you explain them, okay, your boss bought all this machine and you're not using the memory. So here also, I mean, use the memory. I mean, like you said, I mean, a lot of the quotas, they're credits. Like with the bank, I mean, if you get a credit and don't use the money, I mean, it doesn't hurt you. It doesn't allocate anything. It's only like, I mean, resources you allocate and suddenly 1,000 processes are allocating the same amount, then you might have to think about it.
The 1960s idea of, I'm going to keep 50% free memory all the time, you know, blah, blah, blah. And then my business grows, so I buy more memory so that I can have 50% free all the time. You spent, you know, how many thousands of dollars in this memory? For God's sake, use it.
And that's why we're now on x86. If you still have a swap file, you can delete it. Swap file are not used. We don't page out anything anymore. We just keep it in there. So basically, there's no page file support. I mean, there's a page file, yes, but swap file, there's no way that you can even get rid of something. So
It's slower to get it back. It's so violent.
no.
I think where people get better at quotas is that they're working on systems, they're migrated from a system, or migrated from a system, or migrated. So those quotas were established 20 years ago and never touched.
Oh, yeah. They're not sacred. I mean, these numbers, okay, there is nothing magical about any of those values, except that they're too small. That's what they have in common. So this quote dates back a long time when I was working at Oracle, and Bill Wright's one of my coworkers, and we were fixing some bug. I don't recall the details, but I wrote this down then because it's exactly what I want customers to hear. Complaining about your problem will not make it better.
And that's why you walk it out, because you come there and say, okay, we have to do this and this. Yeah, but you cannot change anything. I mean, or you can change it in 4 weeks. And I say, okay, then I go home because I cannot fix your problem. And it's like you go to the doctor and whatever. I mean, my arm hurts, whatever, fix it, but don't touch me, don't give me any whatever. I mean, so.
All right, so let's talk about a couple of little cases. Everything we're going to talk about here is true. I've changed the names to protect the guilty in a couple of cases. The innocents. So these are all true live stories. I'm only going to lie to you a little bit. Okay, so this is relatively recently, like a month ago. Customer builds brand new superior systems. They're better in every way, better storage, better CPUs and everything. And so we replicate their existing environment to this new environment. And the database administrator comes back a day or a week later, whatever, and they're complaining that their some database restore operation or whatever they were doing is 4 times slower. Like, okay, first of all, critical thinking. Nothing on this new environment is 4 times slower. Everything is the same or faster. So I can eliminate the environment, the computers, as the source of the problem by itself. And sure enough, we reproduce their problem, and this is their data. Their existing system does it in whatever it is, 21 minutes, whatever this thing was. I think it was a restore, and then the new environment takes just over an hour. What the heck? The I/O counts are effectively the same. The CPU time is surprisingly more in the fast case. I never bothered to follow up on that. Anyways, so what does this tell us? I/O counts the same, elapsed times way higher. Are we I/O bound or CPU bound? All right, good answer. You guys scared me for a minute. So yeah, we're I/O bound, which doesn't make any sense because we've got 16 gig HBAs and storage with memory, RAM, yada, yada, yada. No. So host-based mini merge is one of the things that, as a performance person, I don't like. It's great for a lot of stuff, but performance is not one of those things. And what you're doing, like a lot of things in computing, life's a trade-off. You know, I'm going to pay here, I'm going to pay there, but I'm going to pay. So with host-based mini merge, I'm paying all the time to save myself in case I have a disaster. Okay, is the mindset. We can talk all the details. It's not really all important. What is important is the old development environment, which we replicated, didn't use host-based mini merge at all. Their production system, all the reset thresholds were set at 1 million blocks or whatever, some big number. The new system, when we mount all the disks, inherited a 50,000 block bitmap size. And that's where all the performance went. Again, 100% innocent. Everything on the system works. Everything looks fine. But that was the difference. So even though nothing changed, that was the change. Do you want to talk this one through?
No.
This is one of my favorites by far. So we migrated a customer from hardware to an emulator, the Karen emulator in this case. Everything went well. They've been testing for weeks and months, and everybody's happy, and it's all good. So I get looking at the collected data, and this is interrupt stack time graphed, and I recognize now it's very difficult to read. Let me try to explain it to you. So for the last weeks, interrupt stack time is hovering 5–10%-ish. And interrupt stack time, if you're not familiar, is the CPU time on the computer that's spent doing I/O overhead, talking to the device. It's a lie, but it's not important. So right in here is when we migrated them to the emulator. And now interrupt stack time is hovering at 30%, 28, whatever those numbers are. 10 times more. And it's persistent and it's consistent. It's weird as stuff. And so scurried around, came up with some ideas and this and that and the other thing. And I reproduced it in-house. We took a little lock traffic simulator program that just made lock stuff happen. And sure enough, I'm spending 65% of my computer's time just doing lock traffic. And there's no work going on. That's really strange. Like, why would this be? And after a little bit of PC sampling, I discovered that, you know, of that 65% CPU, like 90% of all of the PCs were on one instruction. And the instruction is in the systolic cluster code, which is where all the cluster communication, you know, going into the computer and coming out of the computer goes through. And it's an instruction memory barrier. Now, an IMB is used when there's new code on the computer to tell the processor basically there's executable instructions that may have changed. Pretty benign.
Stop and wait.
Yeah. I know that there's no new instructions showing up right here at this time in the cluster code. So dig a little bit deeper, and I find this comment
It's not me.
in, what's that?
It's not me. I don't have a middle name.
Yeah. I find this comment in the OpenVMS source code saying, and this, I cut and pasted this, fix the EB6 bullcrap. So as it turns out, I got in touch with the guilty individual. And he's like, oh yeah, there was an alpha chip that contained a bug in the chip. And under a certain sequence of events, the chip chose the wrong branch. It was supposed to branch this way and it branched that way. These chips are in the field. The customers have been sold the computers. So what do? So rather than, you know, warranting the computer or fixing the chip or any number of things that a normal person might do, instead, the decision was made to insert 6 instruction memory barriers at strategic locations in this module to cause the branch prediction logic or the branch prediction information to be thrown away. And then it chose the right answer.
And at that time, it took me a long time to convince the chip, like I can't remember who it was, like, I mean, to convince them that the chip is doing the wrong thing. He was trying to convince me not. And a few years later, he publicly apologized to me. The Pete Bannon.
Ah, really?
Yeah.
I did not know that part of
Yeah,
that.
yeah.
In the customer support center, when we had that problem, we were actually told never to tell the customer.
What?
And we would find an excuse
Ah.
to order the new CPU.
Hmm. So anyways, so the dirty little secret is on an emulator, the IMB instruction is really punishing because the emulator takes alpha instructions and converts them into x86 instructions and executes the x86 instructions, and all this happens on the fly. So you're in the cluster code going along, you get to the IMB, we throw away all of that cache stuff. The next instruction to be executed causes all of this stuff to get retranslated.
And then in a year from now, when Norm is giving his presentation again, there would be a next slide where the IMB is replaced with the probe instruction.
Yeah, so anyhow, I mean, this was, all of this took a little bit of time to sort of piece together what was going on, even though we had all the evidence. And so because all right, so again, I did something bad. They run an unsupported version of VMS from a company which no longer even cares about the operating system. So I used patch/absolute and I changed those 6 instructions to no ops. And this is the result. So this is the next segment of that graph where we went, from here down to nothing. Yeah. I guilted. So the person who wrote this comment down there, I obscured their name. I sent them an email. I guilted them into making a patch for VMS to do this. So anyways, keep up to date on your alpha patches. If you're on an emulator, check out the systolic cluster reserved one or whatever it is, sysgen parameter. And then, and if you're on an older version, come see me. All right. Another true story. I'm not making any of this up. We got a call one day. And the problem statement was, we are seeing we're seeing performance issues starting yesterday. Fine. I mean, this happens all the time. What they really meant was FTP is slow. The throughput of FTP is not good. Their development environment is fast, whatever fast it is. Their production environment is terribly slow. And these are modern integrity servers with 10 gig LANs and 16 gig HDD, all the stuff. So this is really funny, but we ended up going through everything. It's a 6-node cluster. So we checked the bandwidth of the disks and the network, the memory latency, memory bandwidth, the LAN switches and error counters, all of this stuff. And the customer finally said, well, why don't we just reboot the cluster so we can get back to where we were the day before? So reboot this cluster, doesn't make any difference at all. So as it turns out, our friends in TCP/IP included a volume knob, a speed limiter on FTP. And so they gave you this logical name. Apparently, the documentation was limited on the amount of characters you could put. So it's in writing window size, they truncated down to WinSys. Changing the window size of the send and receive buffers can improve network performance, is what the documentation says.
Change. No, that made me bigger.
Yeah, it doesn't say what to do. It just says changing the size can improve performance. So apparently somebody on the development system figured out that whatever that is, 1,000,000 is the right number. And their coworker on the production system figured out that 4096 is the right number. Been that way since years. But nothing started yesterday. So the takeaway from this story is don't fall into groupthink. Okay? And had we, at the very beginning, gone back and looked at all their log files and figured out bandwidth, it's always been this speed. Nothing changed yesterday. You get into these situations where there's a conference call with 20 people on it, emotions are high, we're all trying to get together and solve this terrible problem. But I got into this 48 hours after it started. So they've already been through 48 hours of emotions and passion and stuff. The number one thing that we talked about was gather the evidence and just assume that it started yesterday. Be specific with the problem statements. Don't come to me and say fast or slow.
It's the same thing, like all the graphs that he's presenting. I mean, don't go a day back, I mean, go a week back and like follow the trend. I mean, there might be a spike always at 10 o'clock at night for an hour, and then suddenly the spike is at 8 o'clock because the job started now 2 hours early or whatever. I mean, look over a longer period of time, not when I tell it started yesterday. I mean, look.
Yeah, don't,
Yeah.
it's hard. I mean, absolutely. They're paying us to help solve their problems. So I got to be respectful of that. At the same time, they're paying me to follow these breadcrumb trails through the woods that don't go anywhere.
But we have now worked, like we said, I mean, for many, many years with real life customers. We have seen their life and learned a little bit along the way. So that helps.
That helps a lot.
Sometimes.
I mean, you come in with some credibility and you say, stop. Tell me what the numbers are.
And also a lot of times, I mean, like the local people, they have been working in this environment. I mean, you need a fresh set of eyes, or they also try to protect their own environment, or they know they've done something wrong and they want to cover it up, but it never pays off. I mean, it's much quicker to get to the problem and say, hey, I did this and now it doesn't work anymore. Something like that.
So I just realized there's another interrupt stack graph. And this, again, the graph on the slides doesn't really tell the story. But since weeks and weeks and weeks, interrupt stack time is down here at nothing. And in the last few days, all of a sudden, it's like 100%, effectively 100% of one CPU gets spent on the interrupt stack. And this is a super simple application. This particular customer is, you know, it's a very primitive, simple application. Gets something off the network, drops it on disk, and then sometime in the future pulls it off disk and send it back. That's it. Well, what happened was the IT department was rolling out the next company standard desktop to all of the Windows users, and it included an updated version of whatever terminal emulator they're using, which I can't remember what it was. Say PowerTerm, I don't, one of them. And some. And with the new rollout, you got all the connections built in, you know, so you can open up the connect to window and double click where you need to go and stuff. And one of the parameters in the terminal emulator is how often to do a keep alive message. As it turns out, in this terminal emulator, if you set keep alive interval to 0, it doesn't turn it off. What it does is that there's no delay. So you can see what's happening here. The first day they rolled it out to one department. And all those people are now doing keep alives constantly. And then a day later, they rolled it out to the next department and double it again. And the next day. And so by the time they finished updating everybody in the company, these systems were at 100% interrupt stack time, just doing constant keep alive messages. Now, the funny part is there are no counters in VMS that show this. because the null, whatever what are they, the timing mark gets thrown away really, really early in the network processing. So we get it, it's a timing mark, that's nothing, so it just gets thrown away. So it doesn't even get far enough through TCP/IP to start incrementing the counters. So we use TCP dump for a minute, monster files. I ran again for 10 seconds, and ran Wireshark in it, and that's all it was. Millions of timing marks. And then occasionally you'd see a key press from somebody, and then the echo back of the letter that they were typing.
They waited for it.
What's that?
They had to wait for that letter to get there.
Yeah, it was amazing that it worked at all, though. I was able to log into the system and it functioned. All right, does anybody here use databases or index files on their VM? Yeah, everybody. So I worked for RDB engineering for a long time, and we developed some years ago some new software, and because it was new software, we started telling everybody to use it because new software is obviously better than the software it replaced. So in this particular customer's case, they have some table, and it includes a column that says it's the to-do flag, right? Processed or not processed. So a new item comes in, it says not processed, you do the work, whatever it is, you change it to process, and then it goes away. So it's just a little queuing system, super primitive, not all that important. Being good database administrators, as we are, we came in, noticed, wow, you've got a table with a gajillion, hundreds of thousands of duplicates, and you're using the old style index. You need to be using the new style index because it's better. And they call up the next day and their system doesn't work anymore. So what happened, and this is just for illumination of where to look for problems. So by default, when you insert a duplicate value in an old style RDB sorted index, same ideas as the index in RMS index file, the new entry gets stuck at the beginning of a chain. And then later on, when you go remove that entry from the index, when I change that flag from process to or not process to process, I look in the chain, I find it right at the front. I remove it from there and I put it somewhere else. All well and good, very fast. And in this particular, it's got 1, 2, 3, 4 IOs plus the update. So it's a last in, first out. RMS, on the other hand, chose a different model. And when you insert into a RMS index file with a duplicate key, it follows that chain all the way to the end, even if that chain is tens of thousands of buckets long. So to insert one record might take you 10,000 IOs and the locking and the contention. And when you go to delete that, remove that entry from such a chain, you've got to go scan the entire chain to find it, to pull it back out. Ugly. However, RDB's brand new fancy sorted index solves everybody's problems because we added this fancy byte-line bitmap compression. Fascinating bit of computer science. So what happened is when we converted the customer, now we have a sorted list of these entries on the key. So we have to scan the list, find the right place, break the list apart, put the new entry in the middle. But because they kept adding records to the database, it's always at the end. So we took a bad problem and made it infinitely worse. So be aware if you have indexes on things, the actual behavior.
On our indexes, if it's a unique index, we use vanilla as for NVs through the rank protocol.
So sorted rank on your duplicates, it depends on what you're doing with it. So it solves one set of problems of the discarded pages, generally. But if you have zillions of duplicates, then you start suffering from that problem that we talked about.
So if you have zillions of duplicates, you change it back to a regular sorting.
Are you having a problem? Oh, that's another thing we were going to talk about.
Yeah, if it works, don't make it, don't check
What
it.
follow best practice?
Working them pretty good.
Don't go looking for problems to solve. They will find you. Okay, so yes, if I scurry around and look for problems like this, I can break lots of stuff. But usually, in most customer cases, somebody will complain and then I'll get involved. And so, yeah, I mean, looking for problems, you're gonna find them. Fixing problems which don't exist, you're going to create them.
Nice to hear.
No, I mean, Kristen and I have broken perfectly fine working code because we didn't like it.
Each other's code.
In some cases. All right, so, how are we doing on time?
20, 50 minutes.
All right, so let me skip through some of this stuff. Okay. Customer, financial industry, different than some of the other ones I talked about. They have a multi-site cluster that used to be 5 kilometers apart. The board of directors said that's too close. What if, what if something bad happens and both sites go down? And so they moved the disaster site to, I don't know, 30 kilometers away, whatever. Apparently you can't have a disaster that big. And performance got bad at night, and one of their overnight jobs got really awful. And they're like, oh, but we have dark fiber and latency and this and that and yada, yada, yada. So what we found was they have in their application a transaction log. Think about like a journal file where every trade event, whatever it is that they do, they write to disk. Okay, so new trade, do the work, write it to disk, it's done. So everything is replayable, durable, yada, 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 all those things. At night, their overnight processing has to reinitialize this transaction log to start the next day. And they use the same code to do write a block, write a block, write a block, write a block. So instead of having all day long to write all these blocks, they have to do it all in a row. It takes forever. Bad things happening. They weren't able to, they were worried about opening the exchange tomorrow morning. And fortunately, we lucked out. They said, why don't you, and it all happens in one command feature, the whole overnight initialize thing. Why don't we copy the transaction log file off of disk, put it into a DECRAM device, run the reinitialize, and then copy it back. Would that work? Oh, yeah. So seriously, it's every bit of 5 lines of DCL code that got modified. And this is a customer, again, that an emergency takes 6 months to resolve. And so this is 4 o'clock in the afternoon on Tuesday that we put it in. And what you'll see, and again, it's the awful graph. I don't know who makes these things, but way down here is the IO rates before, and it was doing 1,000 or 1,200 IOs a second. Pretty impressive. But that night it was doing 30,000 IOs a second. So infinitely fast. If you haven't used a DECRAM disk, you're missing out. Even for things that don't need it, it's fun to do. The result was we went from 1 hour and 13 minutes. They have 8 hours overnight to resolve the bank. So we went from 1 hour to 2 minutes. And I said, we can optimize this further if you let me use fast IO. Stop. So I was incredibly unpopular the next morning because the overnight operations team used this hour to go down, get a coffee, smoke a cigarette before they came back to work. And now it's done. So yeah, they were earnestly upset at me because I chopped an hour out of their overnight. So if you don't use DECRAM, you ought to find something that you can use it for, even if you don't need it.
Outside the trick we use it for is I'm building up software, I'm compiling, so compilers make object files. They live for a short period of time. I want to then take them, write them to insert them into object library over and over and over again. All my objects go to a RAM disk. The OLB that I'm turning insert is in the RAM disk. When I'm done with the build part, copy that from the RAM disk back to.
Because a lot of this stuff, this can, if it breaks in the middle, like people are afraid, like if the computer goes down in the middle of the thing, your DECRAM is gone. But this is a restartable operation.
Yeah.
You're saying you build it again. I mean, it's like,
Anyway,
yeah, and
it's helpful.
yeah.
Don't be afraid of memory.
And but to add on this one,
Yeah, yeah.
what Camille said this morning, I was also in the customer banking, large US bank, where also like the more IOs, the more was beating them. So they had also like the database is slow, but then you prove the database is fast, and at the end the network is slow, because it was doing a gazillion of small requests. And they said, okay, we need a faster. So they went to a 10 gigabit even. But what they in the end were beating on was the interrupt on a single CPU. I mean, that's the law of physics. I mean, you can only do as many interrupts and handle like with the zero time
Yeah.
packet. So they would have been much better off with 2 1 gig than 1 10 gig. So what Camille said this morning, yeah, it shouldn't work on a 10 megabit by bigger, but sometimes if you have a 1 lane and you just make the street better, it might not help. You might have to make 2 lanes to get the throughput through. So that's also things to look at. Yeah.
Excuse my ignorance, I'm a database administrator, not a system manager. But I just made a question and asked her, what's a DECRAM disk? And I looked at today's itinerary or agenda, and at 2 o'clock, Norman Ricker's talking about logical disks. Are they the same thing?
No. The short answer, no. But you can have a logical disk on the DECRAM. Basically, I mean,
I'll bother Gary later.
no, but in the short, like a DECRAM is just a piece of memory which looks like a disk, it feels like a disk, and you can treat it like a disk, and we as commands will work and think it is a real disk. But when the system shut down, this is gone, basically.
Yeah, in this particular instance, if I remember, it's 128 gig titanium i6 something or other. And what we did was we created a 16 gigabyte DECRAM device. So there's a disk dollar something, whatever it is, disk dollar fast. And it's a 16 gig disk that's infinitely fast. It's not going to make your CPU any faster. In fact, the goal here was to increase CPU use, shorten the duration. But yeah.
And that's again like the metrics. I mean, some people might complain. My CPU, I'm using more CPU. I have less idle time. I mean, the idle time is non-useful instruction. So that goes back to you want to have the CPU useful work.
Yeah.
Not wait.
Yeah, my goal ultimately at the end of the day is to increase your CPU utilization and reduce the length of time your application runs. That I've been successful.
I'll turn off high.
Has anybody used high water marking?
Back in 20 years ago.
Yeah.
Sometimes, if you're careful, it's not by default.
It's on by default.
To still use OpenVMS, your system just has high watermark.
Yeah.
First thing I do after install is I turn it off.
I mean, we have still, or we had pieces in VMS over the years, probably less and less where engineers developed a new feature and put it in, but you had to actively change the system parameter to turn it on because they're afraid the new code might not work. So.
But and I changed the default in RDB, or I guess it was a Oracle database. Super performance win. It's absolutely the right thing to do. And sure enough, within weeks, we had customers complaining because something broke. Sorry, you know, again, it's like the better for the all or the better for the one. Yeah, it got better for 99% of all the customers, but one guy, it got worse, and I'm the guilty party here. So-
And going into the discussion, don't look for things to fix necessarily. I had a customer that happened to be that same customer. That I turned off the high watermarking, and they were depending on the high watermarking, and I didn't know that broke things.
Yeah, so actually, yes, that's their application, this particular case, their application was designed by a bunch of scientists, I mean, very smart people, thought this through a long time ago. But they create all their disks with high water markings, so they don't have to initialize their files. Okay, so what do you want to, what I would like you to walk away from this presentation with, or, you know, I want you to walk away hungry, but I also want you to understand that perfect is the enemy of done. Okay, do not solve every problem. Solve, if I can get an 80% solution for a little bit of work, done. You know, I don't, it doesn't need to be perfect. It needs to be good enough. It needs to be better enough. But you have to do something. It's very difficult to achieve change without making a modification. Think about these things. So this is a quote from automobile racing. 100% doesn't even get to the starting line. Okay, if I wait for my car to be perfect, I won't even be able to start the race. So avoid perfection. Focus on excellence. Focus on better. 10%. There are days where a 10% performance improvement, I'd give my left arm. I mean, absolutely, that would be a miracle. There are days when 20 times faster is not enough. But, you know, scope things out. If you're a perfectionist, I don't even want to hear from you, because you're going to be disappointed. There is no perfect. You can tune something. We can do IO and interrupt alignment and fast pathing and all this stuff. And it's going to be right for about an hour. And then something will change and it's going to be wrong.
Yeah, it's like with the bank. I mean, you ask them, so how long can you end of day processing one? When does it have to be finished? If 6 hours is good enough, anything shorter than 6 hours, then once you reach that goal, then
Yeah,
work on something else.
yeah, making it be 1 hour is not going to make anybody more happy. Give up. And follow your nose. Try it. All those compiler switches, all of the command line options for the convert command. Try them. Convert, is it work files or secondary files, whatever it is. Use it. It's free. The worst that's going to happen is you're going to learn that it doesn't work.
Convert also is
Yeah.
a good example, because like if you have to dig a trench, I mean, you can have one worker doing a lot of things, or you can have 10 workers. And a lot of this sort or convert, I mean, the default is still back like 2 workers, or you can have 10 work files or a sort file and spread them out or put them on a RAM disk, whatever. I mean, stuff like that.
Yeah. Oh yeah, I've done awful things like put sort work files on a RAM disk, because sort 32 just does what it does, and I couldn't make the work files go away. So burn up some of that memory. Plus, when I go to a customer, it's not my memory. It's not my computer. I don't care. You got to gather data. You've got to be able to draw graphs. First of all, because there's going to be a manager at the customer site, and I have to be able to show them something you can understand, which is a graph, and then a little balloon pop-up that says what the graph is about. It's so obvious. So here is hourly averages over, I don't know, months, 3-4 months. Kind of stands out, doesn't it? But if I look at the system here, or here, or here, it just looks normal. Like, I don't know there's any difference. But once you can draw stuff out over time, it's real obvious the outliers. And almost always the outlier is a guilty party. Runaway process, bug, whatever. All right. Advice I give everybody. Use set prefix in all of your command procedures, log files, so you have timestamps. A lovely bunch of developers. I really like these people. I mean, they'd be great neighbors, but geez, they went through and modified tons of command features and did like show time all over the place, so they could go back later and figure out how long steps took. You could have done all that with 2 commands. And then every line of your command procedure would be timestamped, and you could write another command procedure to go back and subtract the times and find out where your time was being spent. Super easy. Show process / accounting, yeah. RMS stuff, bottom line, do fewer IOs, do bigger IOs. Compiler optimization stuff doesn't really matter, right? We had a customer who complaining about a performance problem, the database had nothing to do with the database. They recompiled their application. This is a commercial trading system that's used at multiple exchanges all around the planet. They recompiled it / optimized. 50% faster. Not a line of code change. So why do you compile it, no optimize? Well, if we ever have to debug it, you know, we want to be able to debug
Because
it.
the step like.
Yeah, we're gonna step. How many times in the last year have you had to do that on a, you know, production commercial trading system? Never.
The depth.
I'm just telling you.
And if they would read the manual, the RTA manual, there's levels of optimize. So we will optimize a lot, but keep things in a sequence to earn that stepping ability as best as possible. So you may not get the 50% improvement. You kind of got a
40.
yes.
Good enough.
Good enough.
Then
Okay. CPU time versus elapsed time is your takeaway. Don't tell me it's slow. Tell me what it's doing. Interview. Ask the customer the right questions. Isolate the useful answers from the opinions. And identify what the problem is. From there, solving the problems is generally straightforward.
It's like with the doctor. You go to the doctor and you tell him what's wrong with you and you want him to fix it. Doctors don't like that. You come there, you tell them the symptoms and what happened or whatever. But if you try to tell the doctor, okay, this and this is wrong with me, they don't usually like that. I mean, here's the same thing. You come to a customer, they already tell you what's wrong. So if they know, they should fix it by themselves. They don't have to call me. But yeah, trust the symptoms and get data and
Yeah, once you're there, solving the problem is usually pretty straightforward, but it's getting to the problem is hard. All right, anything else? Comments, thoughts? I hope somebody walks out of here and goes home and finds something to fix, even if it's not broken yet.
I wish they need this. Yeah.
Yeah. Go home and find something that needs me to fix.
Regarding the log files and those.
Mhm. Zip prefix, yep.
And again, when you submit a batch, it starts logging now and we can look at it.
A set output.
Set output rate.
Yeah.
In my login.com, I've got probably 30 seconds. I don't want to do it constantly because I don't like IOs. On the other hand, I'm impatient and I don't like waiting. And I found
Right.
30 seconds is about the threshold between when I get anxious.
it's in the default.
Yes, that's it.
I think the default is nothing.
Let's do a help.
So like, I mean,
Oh yeah, by default, it'll wait 127 blocks or
Yes.
something before
like
it
enough
flushes.
for you to go to the.
Yeah.
To have a smoke or whatever.
I think it's something, I don't need it when I'm just, anyone that, I'm sure it's gonna work. Well, I'll turn it off, but I just want to know that that's.
I'm also a disk space snob. Like, I don't like having lots of big files laying around and stuff. So I started out, I don't want log files to have a lot of information. And I very much have shifted toward put everything there, as long as it's not costing me performance. And yeah, in the unlikely event that I need it, I can get it. It's too frustrating to see a log file that says set no verify and then access violation.
Yeah. What?
Yeah, it's like, I don't even know what you did to cause that. What else? Okay, everybody's hungry. That's good. All right, well, thank you for coming.
Yeah, you should.